Hello, I was just letting the mean Zoom lady talk over me. Um, Nice to see everybody. Recognize a couple names in the gathering here. I'll just start off. As Emily said, I'm Garret Giordano. I'm the first GIS Program Manager for the Alaska Railroad. And when I was hired, my supervisor created my position partially to accomplish a task of replacing a old application that was very inefficient and gobbled up bandwidth like crazy and did not um, was not good because the Alaska Railroad has very limited connectivity, um, in the sense of about half of our railroad doesn't even have cell coverage. So what that means, and I want to make sure my screen is sharing correctly. I'm not getting the halo, Emily. Can you see my screen?
Yeah, I can see your screen.
Okay, cool. It's not highlighting it, so I was making sure. Um, anyway, so we do not have cell coverage for much of our railroad. So a lightweight application that can work anywhere, obviously, you do have cell coverage, including on the trains themselves, that gives the location of the train, for various purposes. A lot of the train crews use it, including the crews that are getting on the train. Um, but yeah, there was a multiple business needs. I guess is the moral of the story. Some of it's public, and some of our passenger stuff is public facing. We have had passengers wondering where the train is when it's late. Um, as you can imagine, there's many reasons up here why a train could be late. Anything having to do with weather. We hit a lot of moose a lot of the time, and it takes sometimes they get stuck under the train, and that they have to remove the moose from under the train, and that can take a while. Anyway, um, I was basically partially hired to solve a business need, being real-time train location in a lightweight application. Uh, non, I kind of covered some of these, some other reasons, so the previous solution I mentioned was a Google Earth real-time KML it would load the entire base map on Google Earth in and of itself using its um, default images, and the 3D models are turned on by default. So it was an absolute bandwidth hog. The KML was clunky, didn't work well. If you selected multiple trains, it would just bounce around the map like crazy, and it was just terrible. Um, Another thing that we brought into this, our dispatchers need to know. We have a lot of earthquakes up here, as you may or may not know. Um, and they are required to notify and activate slide zones. And there's a bunch of like track inspections that have to happen within a 100-mile radius of the epicenter of a earthquake that is 4.6, a magnitude of 4.6 equal to or greater. So what back until we had this application, they would just manually calculate the milepost to and from of the affected area in which they needed to meet those criteria in order to ensure safe operations and meet federal regulations. Um, Previously, we also had absolutely no mapping or real input that anybody could use easily internally, for forest fire information. So there aren't any to look at right now, thankfully, but we have a layer from the BLM that is managed by the BLM that is semi-real time. I think it's updated about once a day, maybe a couple times. And basically it shows us our active burn areas. I have a bunch of queries on it, and it only shows the active fires, and obviously relative to the railroad, which is important. Um, and then the tide information is also in here, and that comes from the ArcGIS Living Atlas, from NOAA. And that's important because we are not connected to the lower 48 or the North American rail network. All of our rail cars come in on a barge. Um, Often most of the time they're fully loaded, when they come up on the barge, and then we bring them onto the rail and then build the train at the dock and then take it wherever it needs to go, usually Anchorage or Fairbanks. Um, that's a pretty special thing. I mean, there's other rail barges in the world, but we're probably the biggest railroad that's dependent on it. Um, so as you can probably imagine, well, so another thing in case you don't know, Alaska has crazy, crazy tides. Our tide swings are massive. And so knowing where the tides are at is very important for the rail barge operations because you have to, you're lining up a barge with a railroad and then trying to roll, you know, hundreds of tons of stuff onto tracks from a barge. So knowing where the tides are at is very important, and timing your operations and your locomotive placement and all the operations side of that is very important, having tide information. We get a lot of rain up here. Much of Alaska is a rainforest. So stream gauges, flooding, like highlighting the stream gauges are nice because it highlights where we may have washouts potentially from bridges or just all sorts of, whatever could cause washouts, rainfall, flooding. So stream gauges also coming from ArcGIS Living Atlas. We have a few different weather data sources. We have some internal weather stations that are feeding into, our weather stations are feeding into the National Weather Service. And then I've got a layer that also queries the weather stations by a predefined location. And it links people out to the National Weather Service site for that location based on the URL. So the products that we used in this real-time solution is a Django Python library, and this is on the active trade control side. So what that means is, for those that don't know, railroads are mandated, I can't remember the criteria, but we are mandated to have positive train control installed on our trains. And what that means is, if a train runs a signal or is speeding, I think there's some other criteria as well, the train will automatically go into emergency braking and stop. All of that, in order to do that and monitor it correctly, requires real-time information to be sent out from the locomotives to assist. There's a whole server farm system. It's very complicated. Anyway, we harvest information from that. We had a developer on that side create a GeoJSON feed for me in the Django Python library, and it's served out through Apache on an internal site. Anyway, so then obviously we're harvesting that GeoJSON and creating features with the GeoEvent server. We're actually updating features. So basically, instead of creating a new location every time a message is received, which is every 2 seconds, we just update a point using the locomotive number because we do not have duplicate locomotive numbers. No railroad does. So that's kind of nice that your primary key is built into your operations. Makes things very easy to track. Obviously, our GIS portal, all of this is internal except for the passenger train application. And we're serving that out publicly from portal. And the applications are all built in Experience Builder. And then, as I mentioned earlier, a bunch of ArcGIS Living Atlas layers. And then we're using an enterprise geodatabase. Get into the benefits of that, but long story short, using a referenced feature or reference feature services rather than hosted feature services allows you to push the refresh rate on the features much higher than it would be otherwise without using a stream layer. Stream layers have a bunch of limitations as far as attributing goes. And it's really unfortunate. I wish Esri could if I could have them change one thing, I would like stream layers to have more functionality to behave more like traditional vector data, but I digress. So that's kind of the outline I was mentioning earlier. It comes in from interoperable train control messaging, which is, how the locomotives are sending their metrics to the control system. That actually gets written into a SQL database and then served out in the Django Apache site I mentioned earlier. Now, I'm sure there may or may not be somebody in the crowd here thinking, why don't you just, since it writes to a SQL database on the other side, why are you not just going SQL to SQL? And do just essentially the messages already exist and just cutting GeoEvent server out of it? Well, there is some convenience in using GeoEvent server, and then our train control system is on a completely different network, and we don't want to expose this data publicly. So we're able to go network to network and from the corporate network to the ATCS network. So we have an GeoEvent server acts as an air gap on my side, and then the Apache site acts as an air gap on the other side. So there's some security considerations there. Technically, yes, it could be more efficient. We don't even need GeoEvent server to do this, but kind of a security thing. People were very hesitant about this and making sure that it was secure. Personally, I think it's kind of goofy because if a bad actor wants to do something to a train, it's not hard to figure out where trains are because there's tracks, and you can just, if you're patient, you sit there wait long enough. I mean, I don't know who would actually stop, but anyway. So on the GIS side, right? So it comes in through the internal feed I mentioned earlier. In ArcGIS GeoEvent server, we pull an external website. Technically, it's not an external website; it's only exposed internally, but that's the connector we use. It's a GeoJSON, which is what I requested the developer output the information from the ITCS system in. And then I have a service published that matches the schema coming from ATCS. And it writing directly to the Enterprise Geo database through a update a feature output connector in GeoEvent server. Like I said, that gives you a higher refresh rate on the display side, so on the experience builder side and the web map side, it allows you to refresh faster. Kind of already mentioned the reference. The ArcGIS map viewer, just like you would make any other application, configure the web map how you want it. I set the refresh rate on the web map. You can I think you can do it on Experience Builder now. I don't do it there. I just do it on the web map. You can do it either way. We've got our crossings, and I'll demo the app later, but we've got our crossings, mileposts. One map, there's actually two maps, one with the natural events and one with just the trains. And then just like you would configure any old Experience Builder application, we just set it all up there and the refresh rate's set on the map and it basically makes it real time. So this kind of goes in more detail. I kind of mentioned this earlier, but the living atlas layers we're using USGS recent earthquakes, NOAA wind buoys, wind stations and buoys. I didn't mention the wind monitoring. Wind monitoring is a huge deal for a railroad. I don't know if you've seen on the news. And every time I see it, I swear it's Nebraska, but in Union Pacific, but trains frequently get blown off the tracks, which is crazy to think about. But yes, straight line winds can derail trains. We up here, we've had a couple of trains get blown off the tracks, and we do a lot of passenger operations. Obviously, you don't want passenger trains to blow off the tracks because that's, dangerous. Like I mentioned earlier, NOAA, tide, current, tsunami, water level gauges. We also have tsunami information on the NOAA gauges. Personally, I would like to, I've been trying, if you guys are, anybody's aware of a good source, I mean, Texas, you may or may not be, but I've been trying to source the warning boxes for when warnings are issued for tsunamis. I have not been able to source that from NOAA or the National Weather Service or USGS or anybody else, not in a format that is easily usable. So if you're aware of that, please help me out. I would appreciate it. And then, of course, like I mentioned earlier, live stream gauges. And then we'll go into the application demo. Let me switch screens real quick, if you'll bear with me. Switch tabs. All right. So this application has been broken into two pages, right? Because if we put all the natural events and all the weather and other situational monitoring information, it'd be kind of overwhelming. I kind of started that way. I didn't like it, so ended up changing that. But if you come over here, so these numbers here are a train symbol. The parentheses is so these are all locomotives. And then, as you can see, I accidentally clicked on that one and it took us to it. The in parentheses 3 represents that is the third the locomotive is in the third position in the train. So in other words, see how these locomotives here have the same number, same train symbol, when a 1, 2, 3. This is the lead locomotive. So this is the locomotive the crew would actually be on, and then these are the two helping units. at least on the front of the tree, and there could be some in the rear as well, although I don't see any additional locomotives on the list right now. This all populates dynamically based on what is present in the feed from ATCS that I mentioned earlier. However, I do have the application set up so that it holds the last known position of a locomotive. So meaning, if you recall earlier, I'm using an update output connector. Well, so if the locomotive is not present in the feed, it just holds the last position and all of the attributes, and just the locomotive stays where it was. It drops dead where it was. We don't have any passenger trains running today, unfortunately, so I can't show you the passenger app. I mean, I can show you it, but there isn't anything in there because it's querying by passenger trains, because that was part of the conditions as well, that I could only show passenger trains publicly. They don't want to show any of the work trains or freight trains or anything else in there, which makes sense. Anyway, you can search by locomotive number as well. So if you know what locomotive you're looking for, actually, you can just do 4004, populates the list. There it is. Take us to it. It's sitting in the anchorage yard right now. So nothing fancy here. You got your standard table legend or layer list legend combo here. You'll notice that the earthquakes are in this map, and there aren't any right now because we haven't had any 4.6s or greater. The dispatchers did want a shorter display time on this map versus the other map, just so they have it more in their face. They may not be paying as much attention to the natural events map, whereas when an earthquake happens, just because there's a big earthquake up in Fairbanks doesn't mean it'll be felt in Anchorage, so there's not really a cue for them to look. I think they have some other notification systems outside of this, but it helps them. We have our slide zones in here. I think I forgot to mention that earlier. So the slide zones are important for avalanches and landslides. You can see I had to map all these by hand, but as you can see, we've got our slide zones marked for the track because they're defined by milepost. From milepost to milepost, or milepost X to milepost Y defines a slide zone. Also important to remember, miles on a railroad are never actually miles. We have on the railroad, so you can't, it's kind of like doing highways. You can't just map, from mile, and I think this one actually might be a mile, but milepost 79 to 80 is not going to be, 5280, right? Usually, because the tracks have moved, and railroads don't like to change the milepost because there's all sorts of things and agreements that have been determined by those mileposts or crossings. So if you change the mileposts based on the length of the track after you modify it from the original configuration, you will screw up all sorts of things. So you have to prorate, right? So what I would actually do, if let's say we took this curve out here and ran it through the water and this track became shorter, I would just equally space 100 points to do hundredths of a mile between the original milepost 80 and the original milepost 79. So there would, in theory, the distance between a hundredth of a mile points along the line would be shorter than they should be. And that's how you do that on a railroad. Anyway, kind of a side note for people that might find that interesting. It's an absolute nightmare to deal with sometimes. We have all of the switches mapped so that the dispatchers can see. We'll go up to Anchorage again and look at the rail yard. So the dispatchers can see where all the switches are. This is useful for operations for obvious reasons. And then we have the signals, right? So something the dispatchers asked me for was they wanted to be able, so sometimes train crews will stop. So like if there's a signal that like is out or they can't see it or something, they can't determine if they have clear track and they can proceed through the signal, they'll stop. And sometimes the dispatchers will see that, and this application allows them to see that, and in case there's no communication, or they're like, as our chief dispatcher put it, what are they looking at? Like why are they stopped? Or if they're stopped at a signal, they're probably looking at a signal, right? And if the dispatcher may have forgotten to give them the green light, or like I said, the light may be out. There could be a myriad of things, but it basically prompts them to contact the train crews. Next up, we have the detectors and AEI tag readers. So most cars have AEI tags on them, and it allows you to ID the cars as they go by the reader. Using it's kind of like RIFD. And we basically that if there's a defect on the car, which these detectors also detect defects. So what that means, defects on a rail car could be a flat wheel, a hot wheel, something dragging, so like the loads or unsecured load, or if a chain's dragging from the load, it can detect all that kind of stuff. The reason, I don't remember, was it East Palestine, that derailment that happened, there was a hot box, so meaning the bearing on a rail car was hot. It was technically within tolerance, and I think that's why it didn't flag, if I remember reading the report right. However, we aren't feeding that data in here yet, and I'll get into that later, but that is something we've talked about, is flagging these in real time if a car passes it that has some sort of defect and meets some sort of threshold. That's a future thing potentially, but and then just crossing stations, all that fun stuff. So this was originally what I was hired to do, is this application. The natural events thing kind of became the bigger project. The reason we did this ended up actually being the sideshow, which is kind of cool, right? Because typical development with stakeholders, they see what you build and then like, oh, we like this, and oh, can it do that? And me being the first person up here has also been interesting, because these people don't even know what questions to ask, right? If they're truly innocent when it comes to what we can do as GIS people. And we there's been a lot of, if you build it, they will come, and just build something that you think they'll like and go from there. And that has worked pretty well up here for most of my users. Just a word of advice if you ever find yourself in that situation. So this is like I said, this is the one that kind of took over. Oh, before I go too far, I do have these maps synced. So if you select a locomotive on one map, it'll take you to it on the other one. So the views are synced. It zooms in farther. I got to figure out why it's doing that. But nevertheless, that is the locomotive I clicked on the other page. Anyway, so the water drops are weather stations. So this one's at our international airport here. And if we click this, it just takes you out to the National Weather Service page for that weather station. Super, super helpful. Quick links based on location. And then, so we have a train sitting in Seward right now, it looks like. They may be delivering, so we're rebuilding this dock right now. Our passenger dock was end of life. That's a major project we have going on right now. They may be picking up freight. They're on the freight track over here. So we've got our freight dock here, and you can see there's a train that's probably loading right now. Kind of fun. But it's kind of a quiet time of year, the winters for us. I mean, like most of our passenger trains stop. We have a few freight trains, but we don't do as much track work in the winter. It definitely, things slow down quite a bit. So the stations with arrows are buoys that have wind speed, and I think these are actually I can't remember if these are the tide or they are one of the NOAA buoys. I can't remember which one they are. They have different stuff. As you can see, the air temperature is not reading on this one. The water temperature, wave height. So there's one of those buoys that I mentioned earlier. There's your color-coded tide gauges. So this is just, like I said, this is just a living atlas layer that I brought in. Super useful. I am querying these by state, so we're not loading a bunch of erroneous data outside of Alaska, because we don't care. These symbols are color coded, so the higher the wind speed, the colors turn red. If you look over our legend over here, they get more red as the wind speed picks up. I did have to run a conversion on these, so NOAA serves these out in kilometers per hour, I believe, on the Living Atlas layer. So I have some arcade stuff running in the background on these to recalculate them to convert them to miles per hour. Because my users are like, huh, our dispatchers definitely don't want to have to sit there and convert kph to mph. What else? There's all sorts of things. There's so many things in this application, I honestly forget sometimes. You can see where the fire data would be right here. Like I said, there aren't any right now, so that's kind of nice because I have it set to only show the active fires. We do have the volcanoes in here. So I don't know if you saw in the news, they were thinking this volcano right here might erupt this summer, and it never did, and it has actually gone back not, I don't know if it's technically dormant, but they definitely are not. There's no warning on it anymore. And then I think that's all the cool ones. I just show you this because, I mean, obviously the train data is ours. We've got a couple weather stations in here that are ours, but by and large, I mean, I'm bringing all sorts of layers together from the BLM, NOAA, USGS, our data. I'm forgetting some others, but it's this application. There's a ton of information. It's lightweight. It loads really well for people in low cell situations. We can get back into detail on how our locomotives transmit their data. As I mentioned earlier, we only have cell coverage for about half of our railroad. So that means that the data that would be sent by cellular connection is actually sent by radio. So the position, speed, heading, all that kind of stuff from the locomotive. They also detect altitude. They send that data by radio. Also, that data on the locomotives is corrected in real time. We have I can't remember how many base stations. I want to say it's 40-ish base stations all up along the rail, continuously operating to correct the locomotive locations. I believe the federal regulations on that is it has to be accurate to like 3 feet. And we were having problems a while back where we do have tracks next to each other where the locomotives would hop the track because it wasn't accurate enough. So the RTK corrections have helped with that greatly. But yeah, so they also receive those corrections by radio. So it's a two-way, right? So the location of the locomotive is being sent out and then it's being corrected in the RTK network. I don't think the RTK network actually sends the corrected location back to the locomotive. It just sends it to the central control system, which is where I harvest my location, where I harvest my locations from. But yeah, the tide gauges are all color coded, similar to how Esri has them in the Living Atlas. I might have modified them a little bit, but yeah, if they flood, they get big and scary. What else? I guess I'll show the passenger train application. This one is public facing. Super useful for people that are wondering where a train is. We do have QR codes in our itineraries in the depot. This gets a ton of use in the summer. My ArcGIS server instance that's hosting the reference feature class that runs the trains for this layer. I think it was getting 100 to 150,000 load requests over the summer. So it was pretty. It was getting pounded on. Our server took it. So my ArcGIS Enterprise setup, we have 7 servers. We've got image server, GeoEvent server, our hosting server, portal, web adapter, and data store, all on separate servers. And then our SQL, our enterprise geodatabase, our SQL instance is highly available. It has 3 replicas. So we've got a lot of, it's a pretty heavy setup. I haven't quite found the limits of it yet. The more recent versions of Enterprise have helped a lot with the efficiency on CPU. I used to have CPU problems, and I tweaked some things, and I for some reason 11.5 works better than 11.3 did on CPU usage. In case anybody's wondering, I don't know if anybody else has seen that. But on the hazard map, I was going to show you. I'm going to see if I can find a earthquake buffer. So in GeoEvent server, the earthquakes are actively being buffered. So I'm feeding the living atlas layer into GeoEvent server. And if it's a 4.6 or greater, it is creating a 100-mile buffer for any of them in the world. I could query this by location. There's not enough of them for me to care. It's not a big burden on the server or anything like that. So I just leave them all. As you can see, there's been 8, and it is limited. So after 12 hours, I think I have it set to 12 hours. Yeah. After 12 hours, it just automatically deletes the feature because it's greater, the event's older than 12 hours. And that's just in the data. So I'm able to make that determination. I have GeoEvent server set to delete it based on this field here. We'll go to this one here. Let's see. So this is what it would like. Obviously, this is not Alaska, but this is the USGS points as they serve them out. And then this is the 100-mile buffer that our dispatchers would see. And if you can imagine, if the railroad is in here, it would tell you the mileposts that they have to alert because they're inside of the buffer. The buffer I do have in a hosted feature class, since the refresh rate on the layer is slower than Esri's maximum refresh rate on a hosted feature class. So I do have this as a hosted feature class. I tried doing a reference feature class. I'm sure it could work. I ran into some technical issues with that. So that's why it is the way it is. Not a big burden, like I said. So I don't plan on messing with that. Anyway, I guess we'll move on back to the presentation. I think that's good for the show and tell portion here. Let me share my presentation back. All right. Moving on from the application demo. So things I'd like to enhance or add right now that I don't have in here currently. Wayside detectors, I kind of mentioned this earlier. I would like to have alerts and messages on them, meaning if an event occurs, what car it was on, right? Because the AEI tag readers are programmed to each car, so we know what car they're on, supposedly, when it detects. So can alert people, and it could alert operations too, not just dispatchers. GeoEvent server, of course, can send out notifications on its own as well. Signal locations, I have added those. I do not have the status. I kind of showed that earlier, but the signals, I something I want to do is like their current status. Are they green? Are they red? Are they not responsive? Are they stuff like that. So that would be something I've looked at adding, haven't quite gotten around to it. I may not be able to. That information may not be available to me. I am limited by what they will feed me from the ATCS system, so kind of subject to their whims. I am currently distinguishing between passenger trains and every other train, meaning obviously freight trains, and then we have maintenance away trains, and then we have locomotives that are running around with no train, like power moves between Fairbanks and Anchorage. So it's just locomotives running by themselves. It doesn't happen very often, but they're a thing. The reason I want to differentiate between the two is for operations, right? I think passenger trains typically get priority. Dispatchers know that because all of our train symbols for our passenger trains start with 200 or 200 numbers. So that's one of those things I could do. It wouldn't really benefit the dispatchers, but there are a lot of people that use these apps that are not dispatchers, and I think it might benefit them. I'm kind of a train nut, and even I can't keep the train symbols straight. There's people here that have the train symbols memorized, and not people that don't even work in operations, and I don't know how they do it. But I think it would be interesting and potentially pretty easy to do. I did publish a passenger train public map publicly. This was our first summer with it. It was absolutely loved by people. It's super simple. I mean, you saw it. There's really not much in there. It's just the track, stations, and the passenger train name and location. It's that simple. And it populates dynamically. I think during the summer, the busiest days I saw it, I think there were 8 or 9, maybe 10 trains running at one passenger trains. So anybody on or looking for those trains could find them in the map, which was really nice. And anybody in the world can do that. I'm currently logging historical data using geofencing at our stations to determine when a train starts and stops at a location. I'm currently logging that data. I'm not doing anything with it. Eventually, I plan on adding some sort of dynamic calculation. I don't know whether that's AI or just statistical calculation in real time on the database side, probably using attribute rules, calculating the ETA of the train, because I now have a layer where I have the track speed on the track center line. So I know how fast that train can go using linear referencing between where it is and its final destination, or its next destination, I should say. So we can give ETAs to the next stop potentially. It sounds really easy. It's fairly complicated in terms of logic and getting it to work for every train, because every train's different, right? Like there's no train running, or there's no two trains running the same route in any given day. They're stopping, they're either going a different direction, stopping at different stops, or they're completely unrelated train. So I'm also kind of holding out hope. I went to Esri QC this summer. We do plan on migrating to ArcGIS Velocity for Enterprise when it comes out. Assuming it releases with any of the, with anything that the current ArcGIS Online version of it has, it will absolutely meet our needs on launch day. But I'm holding out hope because they were kind of, that product team was starting to muse about what comes next, and they're looking at like integrating some AI predictive analysis potentially, or AI attributes, or some sort of having AI assist you in doing data work in real time on velocity potentially. Obviously, they're just musing. I don't know if they'll actually do it, but that would make that ETA calculation potentially stupid easy. So not really worth me investing my time in it right now, because Esri might just do my job for me, which would be amazing. I have a wonderful intern, but by and large, this is mostly a me operation, and it's it's a lot for one person. Like I said, I've got 7 servers, 3 SQL data, or actually 3 databases across 3 redundant instances, replicas of the instance that have all the databases. Sorry, that was confusing. But anyway, yeah, I think, make sure I don't have any more slides. I think that's the end of that. I think we can open it up to questions or comments or whatever you guys want to do with the rest of our time.
Yeah, I'm gonna go ahead and stop the recording here. Let's see.